Hello and welcome to the tutorial for Module 2 of the wastewater treatment part of this course. This is for primary treatment, and we're going to start with Part A, which is bar screen design. The questions for this tutorial can be downloaded from the edX platform. So let's start with question 1, which is determine the head loss across the bar screen if A, the screen is clean, and B, if 50% of the screen is blocked. So we're going to start with the scenario A, where the screen is clean. We know that the incoming flow is 0.6 meters per second, and we know that the pass-through velocity in the clean screen scenario is 0.9 meters per second. So we're asked to calculate the head loss, which we can use with the following formula. So it is head loss is equal to 1 divided by C, and C is the friction coefficient, which for a clean screen is 0.7. And then we've got the pass-through velocity squared minus the inflow velocity squared divided by 2 times the constant for gravity acceleration. Now if we plug in the values for the parameters that we have, it is 1 divided by 0.7. The pass-through velocity for a clean screen is 0.9 meters per second, and that is squared, minus the inflow velocity, which is 0.6 meters per second, all squared, divided by 2 times 9.81 meters per second squared, which is equal to 0.033 meters. So the head loss over this clean screen is roughly around 3 centimeters. Now for part B. We know that the flow is constant between these two scenarios, and flow is equal to the velocity times the area, and that is a constant. Well, we're assuming a constant between these two scenarios of A and B. Therefore, velocity at scenario A times the area at scenario A is going to be equal to the velocity for scenario B times the area for scenario B. Now, for scenario A, we know that is the area of the clean screen. And for scenario B, that is going to be the open area of the screen for 50% blockage. And we know that if 50% is blocked, that means that the area for scenario A is going to be 2 times that of the area available at scenario B. Therefore, we can plug this into the previous formula. So the velocity for scenario A is going times 2 times the area of scenario B is the velocity for scenario B times the area of scenario B. So we can now cancel the areas for scenario B, and we know that the velocity for scenario B is going to be 2 times that of the velocity of scenario A. And we know that the velocity for scenario A was 0.9 meters per second. Therefore, the pass-through velocity when 50% of the screen is clogged is going to be double that, which is 1.8 meters per second. We can now plug this into the formula for head loss. Now, our friction for friction coefficient for the clog screen is going to be 0.6, as the friction will increase when you've got debris and other things clogging the screen. So it's going to be 1 divided by 0.6. The pass-through velocity is 1.8 meters per second squared, minus the inflow velocity is the same at 0.6 meters per second and that is all divided by 2 times 9.81 meters per second squared. And that means that the head loss for the scenario where the screen is 50% clogged is 0.24 meters. So that means that we have approximately 24 centimeters of head drop across that screen, which is considerably larger than the 3 centimeters that we had for the clean screen scenario.